Dr. Robert Gamache was named by Thomson Reuters as one of the world's most influential scientific minds for 2014. He's also currently the Associate Vice President, Academic Affairs, Student Affairs, and International Relations at the University of Massachusetts, while simultaneously serving as a professor in the Department of Environmental, Earth, and Atmospheric Sciences. Despite Dr. Gamache's long experience as an administrator, he was also the dean of the University of Massachusetts School of Marine Sciences for close to a decade. Dr. Gamache is also clearly a very active researcher. Of the list of the 10 most cited publications by the University of Massachusetts Lowell faculty compiled in 2011, he was a co-author on 5 of the 10, including the top 3 papers. Dr. Gamache's current work relates to the problem of line shapes for molecules. Ultimately, this work is important in understanding planetary atmospheres in support of missions for NASA and the European Space Agency. Professor Gamache is married to Suzanne and has 2 children, Justine and Peter, and a very clever dog, Newton, who helps Professor Gamache explain Newton's laws to his classes. With that, let's begin our questions. Dr. Gamache, I'm so glad to have you here. And let's start with our first question, which is, you're bilingual in French and English. Can you talk a little bit about that bilingual background and how it might inform your learning in both the sciences and overall?
Sure. There are a few interesting points of my study of French. I've had the opportunity to work in France often, and early on I decided I would learn the language. I was in my late 30s at the time. First, let me say that I'm dyslexic, and as a child I had really a lot of trouble learning English, spelling, grammar, reading. I still have trouble reading. I'm a little bit slower than most people, especially with the precision needed for reading scientific articles. But my study of French really enforced my learning of English, and I'm really grateful for that. In terms of learning, I use bilingual as an example of why students should study every subject every day. When I say this to students, I often get very strange looks, and I explain that no, I'm not saying study for 6 hours out of class every day, but you should do the homework that's needed and spend at least 15 minutes on every subject. And I use being bilingual as an example. When I go to France, my first couple of days, I struggle to find words. After a few days, it's kind of smooth. What's interesting is when I come back to the United States, my first few days in the United States, I do the same thing. I'll have a colleague or a student come in my office and ask me a question, and my mind is just racing, looking for the English word. Thank goodness, after a few days, it's okay. So why is it we can speak English without thinking? And the answer is that we're using it all the time, so it's just there in our brain. So the example I use for them is if you study chemistry every day, it's right there in your brain. You don't have to search for things. The same thing would work with physics or biology or psychology or history, any subject. If you study it every day, it's just there in your brain, and you don't have to do a lot to recall information. It's just there.
Sometimes I think of it as like strumming a guitar. After you strum it, it resonates and it continues to resonate and send out the sound. And I almost think that that's what we're doing with our own brains when we're just keeping something in mind. We're keeping those neurons resonating a little bit so they don't sort of die away and go off to do other things. So I think that's a vitally important piece of advice. You observed that when you first began studying in the sciences, you stumbled across some particularly effective techniques. Can you tell us a little bit about those techniques?
Sure. I mean, the correct word here is stumble, because when I was an undergraduate, there was not a lot of research on how we learn. And the things I did, I just stumbled upon them. Now they are backed by research, and you show a number of these things in your book, and I can attest that they work. So when I was an undergraduate, I was taking physical chemistry in my third year, and I became fascinated with the fact that you could take equations, you could take simple rules of physics, and with that you could derive other equations. And what I did is I started doing every problem in the textbook. At first it was a little difficult, but with time I could do problems as fast as I could look at them. So I noticed that problem solving in other courses at the same time became easier. It was later in graduate school that I found that there was research, and this repetition actually hardwires your brain. So in my case, I hardwired my brain to solve problems.
Precisely. I think it's almost like, again, like learning an instrument. By practicing continuously, you can bring those parts of a melody to mind instantly and play them and fit them together in new ways more easily, and that can be a very effective technique for learning. Can you talk a little bit about how some of these techniques which you applied in science also can be useful in the humanities and the social sciences?
Well, yes, they are. And, the interesting point is while I was doing this and I was hardwiring my brain to solve problems, and I mentioned problem solving in other disciplines became easier. So it does spill over, and, this technique is not unique to science. This would work with any subject matter that you would like to study. So I do recommend this for my science students and also for the non-scientists. It's a great strategy to develop to get knowledge in a certain area. And again, one of the big benefits is it spills over to your other studies.
Exactly. I think it's very similar to the kinds of techniques I used when I was learning Russian. I tried to do a lot of the additional practice exercises so that I could stretch my brain a little bit and become much more comfortable with the things that we were learning. Let me ask you this now. What kinds of techniques did you develop to handle matters when you found yourself getting stuck in problem solving in your studies?
Well, again, I have to say my discovery was serendipitous. When I started at UMass Lowell, I was entering a new field. And the early stages of that meant I had a lot of studying to do. So I would come home from a full day at work, and I would immediately sit down at my desk and start studying some more. And often I would get stuck on concepts or stuck on problems. Then I had to take a break for dinner, or a few times I had friends come over just to say hello. And what I found was, while eating dinner and conversation, suddenly the answer would just pop up in my mind. And at the time, I would run off and write it down like I was going to lose it if I didn't do it immediately. But the gears are always turning in the background. My wife used to joke that I had two brains. Now when I get stuck, I deliberately take a break and try to do something just to relax, almost thoughtless. It can be as simple as bouncing a tennis ball off the wall or something like that. After 5 or 10 minutes, I tend to go back to the problem with the answer. And sometimes I have to sleep on it. There are many mornings when I wake up and suddenly I have the answer in my brain.
Isn't that funny? And that kind of technique is so useful for so many different areas. One thing, I love that you mention your family on your website. It's clear your family is very important to you. How do you balance your family life and your work life?
Well, that balance has always been important to me. I tell my students and my postdocs that as a scientist involved in research, you're a little like a professional athlete. Every day you have to get up and do something that's going to make you a little bit better than the competition. Young faculty members at research universities live by the mantra, publish or perish. However, there's this tremendous pressure, but if you're working all the time, it tends not to be productive. And as I just explained, that downtime can be very beneficial. The gears are always turning. So being with my wife, playing with my children, or playing with my dogs, has always given me a chance to relax my mind, to refresh my mind so that when I do go back to work, I can be productive.
Has this balance shifted from your early student days? Do you have any particular advice for students who are at various stages in their life's careers?
Well, the shift from the early days to now has been noticeable. When I was in graduate school, I was in 2 programs at the same time. So I was basically a study machine. And that downtime with my wife and my daughter, also playing ice hockey in the winter, tennis in the summertime, that gave me a chance to, I used to say, get the steam out. It refreshed me enough where I could go back, and the time that I spent was productive. Now I work as hard, but I have experience, so things happen faster. But I do realize that the downtime is important, and now I actively seek it out. My advice for students has been, choose a career that you can do something that you love. When you love something, it's always easier to learn. I've been really lucky in my 36 plus years here at UMass, where I can't remember a single bad day, and I'm sure I probably had one, but I can't remember it. So the key point is do something you love, work hard at it, but it's important to have that downtime. That downtime keeps you refreshed, and you don't have to worry. The gears will turn in the background, but working all the time, you get burnt out, and you just can't accomplish what you can when you refresh yourself periodically.
Well, I think that's just fabulous advice. And one thing I agree heartily with is do something you love, but also realize that sometimes it takes a little longer to learn to love certain subjects. So sometimes it's good to be patient too. I do have a last question for you. How does your dog Newton help your students to learn more effectively?
Well, I used Newton in my previous dogs to lighten up the classroom. A picture of Newton, watching a tennis ball fall. I was actually going to do a video where I dropped an apple on his head, but my wife wouldn't let me. I also have a picture that I use of a previous dog, Chaos, who was a 96-pound Irish Wolfhound mix, sitting at a table with an advanced atmospheric dynamics book open. He's got glasses on, and he's punching numbers into a calculator. And then I say to my students, see, physics or science is so easy, even a dog can do it. Of course, the next step is to choose examples that can give students a real feel for the subject and let them realize how simple physics or science in general can be. And that's the real art of being a professor, choosing these examples that make it easy. We have to remember, we're not born, and that includes us, knowing these disciplines, science or any other course. When we're doing this work, we have to lighten it up, but we have to choose these examples. Science is compounded by the fact that people are very uncomfortable with numbers. I use an example where I pass tennis balls around the class so the student can see and feel, hold the ball. Then I ask them what size box could hold 10,732 balls. Being in the United States, I get the answer in feet. And I make it a cube, so it's easy for them to just give me one number. And, I get numbers in the hundreds of thousands. Seldom do I get a number that's below 100. You want to guess what the answer is?
No, you go for it.
It's 4 feet. And when I say that, that just drives home the point that we really don't know numbers. So using examples in the classroom where they can really latch onto it is important, because that's what helps drive deep learning.
That is really the ultimate example of the kinds of things that we're talking about in this course. So, Dr. Gamache, I cannot tell you how much I appreciate your taking the time to be with us here today, and thank you so very much.
You're very welcome. Thank you.